Okay, well, good afternoon. Thank you for joining us at the Naval Postgraduate School's 23rd Annual Acquisition Research Symposium and Innovation Summit. Theme this year is Accelerating Warfighter Capabilities. It's hosted by the Acquisition Research Program and the Department of Acquisition, Finance, and Manpower. Welcome to panel number 2, Engineering the Software-Defined Enterprise, Agile Pathways, MBSE, and AI Assurance. Please put the slides up and advance the slides. Thanks. I am Thomas Sims, and I'll be chairing this panel. I'm joined by our esteemed panelists for topic number 1, the Pentagon's Revolution in Software-Defined Warfare and its Testing Dilemma, the Honorable Nickolas Guertin, the Honorable Douglas Schmidt, and Mr. John Roberts. For topic number 2, digital models to improve the quality of capability needs statements, Mr. Fred Schenker. For topic 3, transforming acquisitions for speed, agility, and effectiveness, Ms. Rita Creel, Ms. Carol Smith, and Ms. Bridget O'Hearn. Next slide, please. I will begin with some opening remarks, followed by the presentations from each of our panelists, and conclude with a Q&A session. Please use the Q&A button at the top of the screen to submit your questions for the panelists. We will address your questions after all the presentations have concluded. So when you do submit a question, please indicate which topic or a panel member you would wish to ask that question. Okay, next slide, please. Okay, Department of War released the Acquisition Transformation Strategy in November 2025. This represents a fundamental shift designed to rapidly field technology and modernize systems at a rate that outpaces our adversaries. The strategy focuses on maximizing acquisition flexibility, streamlining regulations, and utilizing solution-based approach to ensure rapid delivery of critical capabilities to the warfighter. The strategy directs the software acquisition pathway as the preferred pathway for all software development. The strategy identifies system engineering as a critical discipline and directs the use of digital engineering and model-based engineering as part of the development. The strategy identifies the Department of War as a risk-based decision-making organization. All of this is to modernize the acquisition process, making it faster, cheaper, and more effective. These topics you will hear today support the basic tenets of this strategy. So for topic number 1, please bring up topic number 1. I think either Mr. John Roberts or the Honorable Nickolas Guertin will lead that discussion.
All right. Well, until my colleague, the great John Roberts, gets a chance to join us, I'm going to work off of a script here. So pardon me if that sounds a little stilted. Okay, and anyway, he's still trying to get in. All right, so modern software is no longer, let's go to slide 2, is no longer defined by a single domain or single technology. It's an integrated battle space, armored vehicles, autonomous drones, electronic warfare, precision fires, all of it, AI-enabled decisions, systems, all interacting at machine speed. As we proceed forward into the future, the next decade will demand a level of integration, agility, and strategic clarity beyond anything we've seen to date. Meeting these demands will require an acquisition ecosystem that can operate across those domains, fuse digital and physical technologies, and move innovations from concept to capability with unprecedented speed. And I'll add to that, and also change over time. And next slide, please. Today's battlefield is being transformed rapidly. And for whoever's working the slides, there's a couple of other clicks on this page too. Joint force operations now require resilient collaboration across land, air, maritime, space, and cyberspace. What the Pentagon envisions as a joint all-domain command and control, or CJADC2, where sensors are linked to shooters through resilient, redundant communication networks. We've been talking about that for some time. But we're also investing heavily in attributable systems at scale. Swarms of low-cost drones, for instance, can saturate adversaries' defenses, complexing targeting and rapidly exhausting high-value munitions. Likewise, autonomy and AI are reshaping tactics at the edge, enabling unmanned systems, airborne and maritime, to take on the most hazardous missions, from intelligence, surveillance, reconnaissance, to suppression of enemy air defenses. All modern warfare in modern warfare, the advantage will accrue to whichever side can fix and improve their software-reliant systems more rapidly and reliably than their adversaries. Speed will matter in the development lab as much as it will on the battle space. We must therefore identify and codify tactics, techniques, and procedures that enable faster, more effective development, dynamic adaptation to new scenarios and threats, and adequate testing, key point, in software-reliant environments that are physically hard to replicate. These shifts are not abstract trends, and they're happening as we speak. All right, next slide, please. At the same time, our near-peer competitors are rapidly transforming their weapon systems and operational concepts. For instance, China's TF-17 hypersonic glide vehicles signals a new era of long-range lethality, demonstrating how quickly adversaries are extending their reach across the maritime domain. These standoff weapons are central to anti-access area denial doctrine, designed to hold U.S. forces at risk, at distance, and limit our ability to project power. Meanwhile, racks of low-cost, mass-produced, autonomous and semi-autonomous drones, such as Shahed uncrewed combat air vehicles, illustrate an emerging strategy of attrition at scale, attempting to overwhelm our defenses with dozens or hundreds of expendable systems in the hopes that a few will get through. Compounding these challenges is an increasingly congested and contested electromagnetic spectrum, where adversaries can sense, jam, deceive, and disrupt our networks. Together, these trends threaten our ability to command and control forces in both test ranges and operational theaters, and they underscore why investments in R&D are essential to preserving our technological advantage. So I'm still hoping that that John Roberts will be able to tag team here with me shortly, but apparently he's still struggling to get in. Just another reason, by the way, it's so much more useful to everybody involved that this forum should not be remote next year, my personal opinion. All right, going on to the next slide. We also face the challenge that today's acquisition programs and R&D sponsors are no longer satisfied with slow, opaque research cycles. They expect streamlined end-to-end pipeline capability of addressing and neutralizing rapid emerging national security threats. They want faster turnaround, starting with rapid ideation and kickoff. They want agile workflows where iteration and sprints reduce cycle time. And I'm just going to cut that off just to say, and it needs to be excellent, needs to be tested, and when it gets out into the hands of the warfighter, it needs to be trusted. Throwing half-baked prototypes that have only worked in test ranges are not going to cut it. And we are at risk of going down exactly that road if we don't think and act about making sure these things are operationally tested and trustable and changeable as a part of their value proposition going forward. All right, next slide, please. Another key change and challenge we must confront head-on is the advent of software-defined warfare, where code, not hardware, cycles alone, now dictates the tempo of conflict. Software-defined warfare represents a fundamental shift in how military power is generated, adapted, and deployed. Modern warfighting is no longer built around fixed hardware, but around software capabilities that stem from a cyber-secure foundation through AI decision engines into digital twins and simulation environments, that reprogrammable systems that is changeable as a part of their design, and autonomous agents, and ultimately manifest in operational effects at machine speed and changeable. In this paradigm, militaries don't want years for hardware upgrades. Capabilities evolve continuously through code and delivered into the warfighter at the pointy end of the spear as a part of the value proposition. No longer can we tolerate multiple months or even years of doing certification of platforms before they're used in the field. We need to tighten up that timeline so we could continue to drive new capability to the field and fleet at speed. So that adaptability of ships, aircraft, sensors, command systems all need to be able to get smarter overnight through software pushes focused on modular code updates and fast turnaround AI models. Leveraging this agility is AI-driven decision support where machine speed, analytics distill chaos into actionable options. That chaos is something we can both work off of and apply against our opponents. And that will help commanders process torrents of sensor and intelligence data in seconds. Digital twins and simulation extend that advantage by allowing forces to fight the battle in software before fighting for real, rehearsing missions, exploring cross-domain effects, and validating integration at scale. From there, reprogrammable weapon systems carry the software-defined edge into the field, shifting roles through code, surveillance, jamming, striking, all in time, different things happening at different timelines based on their needs. Autonomous and semi-autonomous systems push adaptation even further, deploying machines that sense, decide, and act faster than humans can, teaming with operations in contested, fast-moving environments. Binding all of this together is the reality that cyber operations are warfare. Success depends on defending and defeating software itself, hardening every platform and network against intrusion, deception, spoofing, and electronic attack. Next slide, please.
Nick, I'm online if you decide you want me to help. Sorry.
So we're going to do a World Wrestling Federation tag right here, and John's going to jump in as soon as we get to the next slide.
The software-defined warfare battle space delivers really remarkable agility, but it also creates multi-layered assurance challenges. Really, each area delivers, each capability on this grid has different software stressors or challenges. So the capabilities shown on the left, and there are AI models, autonomy models, cross-platform integrations, all these kind of things. There are also, each of these must be validated and have to deal with different stressors. So as you can see, the grid shows some intersections. Some are green that are well understood. If you advance one more, see where the green is highlighted. Okay, there's the columns of the different capabilities. There's the stressors in the different areas. If you go one more, you'll see the green. These are areas that are well understood. Others are only yellow. If you go to the next, advance one more. Right, thank you. Those are the ones that are partially assured, where there's some capability that's assured, but some that is not. And if you advance one more, those are areas in red. These are the ones that are high risk points where failures are most likely to emerge under operational pressure. So this new complexity of software-defined warfare is a world where every update, every model, every autonomy behavior, and every integration pathway must be tested across a hostile matrix of stressors that actively degrade, spoof, jam, confuse, and even destabilize system behavior. Next slide. Thank you. Addressing this complexity is why rigorous, independent, and innovation-driven test and evaluation becomes the backbone of software-defined warfare, and why R&D organizations are indispensable. Each capability shown in this slide represents a mission-critical assurance function. So validating AI accuracy, verifying autonomy for deployment readiness, assessing cyber resilience, stress testing digital twins for synchronization, evaluating software pushes for instant and reliable deployment, and ensuring the stability of integrated kill webs. These 6 capabilities together show how modern warfighting advantage is earned. The side that can update, test, and deploy faster while maintaining unshakable confidence in every system wins. That's okay. Thanks. Next slide. One more. There you go. We're really at an inflection point, and that's one of the key messages of this talk. For decades, software testing was about automation, faster execution, broader coverage, incremental gains. But today, that model is giving way to something fundamentally different. AI is now embedded across testing workflows. It's not just accelerating testing, it's reshaping it. In fact, an increasing number of software-savvy organizations are using AI across most of the testing processes, and this shift is not incremental, it's transformative. At the same time, the boundaries that once defined testing are also disappearing. The old distinction between pre-release and post-release, it's collapsing. Instead of organizations embracing And instead, organizations are now embracing both shift left and shift right strategies, testing earlier, testing later, and increasingly testing everywhere. What emerges is a continuous feedback loop woven across design, development, deployment, and live operations. In this new model, humans are no longer at the center of every action. They're at the edges, guiding, interpreting, making decisions, and while AI operates in the middle, connecting the entire system in real time. We're entering the era of agentic test orchestration, where autonomous agents don't just run tests, but design them, coordinate them, analyze outcomes, and even improve the system on their own. But this is where the real challenge begins. Because the hardest problem is no longer about running the test, it's trusting them. For example, how do we validate results generated by AI? How do we ensure these systems are reliable, explainable, and secure? And how do we defend against a new class of vulnerabilities, AI-driven risks that are quickly becoming one of the fastest growing areas of cyber warfare? This is the Pentagon's testing dilemma. As warfare becomes software-defined, testing becomes mission critical, not just for performance, but for trust, resilience, and national security. Because in this brave new world of software-defined warfare, it's not enough for systems to move fast. They must be right. Next slide. All right, thank you. Apologies for the technical difficulties. Thank you to Nick for jumping in. I look forward to the questions and conversations to come.
Okay, thank you, everybody, and please submit your questions through the Q&A portal. Next topic will be digital models to improve the quality of capability need statements, and that will be done by Mr. Fred Schenker.
I'm waiting for the presentation. Okay, thank you. Can you guys hear me? Yes?
Yes.
Thumbs up?
Yes.
Okay, hi, my name's Fred Schenker. I'm from the Software Engineering Institute, and I'm going to talk to you today about using digital engineering methods to improve the quality of a capability need statement, resulting in improved program performance. Next slide, please. Next slide. So I'm going to be going through a lot of topics pretty quickly, and I think it's worthwhile to define what I hope you can get from the presentation. The bottom line is that if you're using a capability need statement to define the expected software capabilities that your acquisition program is supposed to provide, then you should elaborate these capabilities in a model. The model development provides the acquirer with an immediate return, as this process will begin to identify the limits of the system's performance, along with potential trade-offs that mitigate future risk. This is accomplished by using the model to validate the capabilities definition, the model-based definition, and by using the model to specify the expected software performance, enabling improved acquisition outcomes. It serves to connect stakeholder needs with practical reality, using a digital engineering model as a facilitation tool. And it's just important to note that the approach outlined in this presentation should have broad applicability to acquisition programs, whether you're on the software pathway or not. Next slide. So we have a little policy math for you this morning. Please click. How many people think that the answer to this question is 10,000.84? Well, I'll give you the answer a little later towards the end. But if you click again, I wanted you to know that the SEI is a research and development organization, and we have 2 active research initiatives that directly relate to this topic. Please click. The first one, the 2 initiatives are called Software Acquisition Go Bag and MB Synergy. The next 2 slides explain a little bit about these topics, and I'm not going to discuss them in any level of detail, but you should be able to access information about them by visiting the SEI's website or by contacting our organization. So next slide, please. The Software Acquisition Go Bag is a new initiative to develop artifacts that help the acquirer when trying to get on the software acquisition pathway, and then to manage the project once on the pathway. I think the Go Bag people, you'll be hearing from them later in this panel, would agree that the go bag has broader applicability than just software acquisition pathway, and the tools being developed could be used by any program acquiring software, whether on the pathway or not. Next slide. And MB Synergy is all about improving the use of digital engineering models to enable better outcomes. It helps organizations define the way that they want to use these models. These organizations could be acquirers or developers or both. Next slide. And this is the agenda. There's a lot of topics. I don't have a lot of time, so so we can go on to the next slide. And I'm sure that most of you are familiar with the software acquisition pathway. This is 5000.87. I'm not going to spend too much time on this slide, but it's important to footstop. The reason why this pathway was defined was to accelerate the delivery of software-related capability to the warfighter. It sort of went on steroids last year with the release of the Secretary's memo directing programs to adopt it. If you click and then click again. The two things that I'll be talking about in detail will be the capability needs statements, which I'll spend a little bit of time talking about. It's a required artifact. And the policy also requires modern development practices. In other words, Agile and DevSecOps. So these are requirements of the pathway. Next slide, please. The capability needs statement is an artifact that keeps track of the software capabilities that you expect to acquire. It's supposed to be a living document, providing a way to update it as capability needs change or new technology becomes available. As I said earlier, it's required in order to get an acquisition decision memorandum to get on the pathway. And our team, our GoBag team, has produced a guide for developing a CNS. And there's a webinar. We have a webinar on the SEI website that explains it. So I encourage you to go look at that. Next slide. Okay, I'm not going to explain Agile. I'm going to assume that most people understand more or less what it's about. But there are some concepts in Agile that you need to think about, especially in the context of developing and delivering capability. The first is something called a product backlog. And you can think about that as an inventory of work to be done. There's another concept called minimum viable product, which is a version of the product with just enough capability to be evaluated by stakeholders. And then the value assessment that provides stakeholders an opportunity to assess what's been done and whether or not it appears to be adding value. Any system acquired by the DoW will be comprised of many capabilities. But for this presentation, this discussion, it's easier for you to think about the concepts by just thinking about the capabilities by themselves, individually. And the main thing that you need to take away from this slide is that we have this thing called a minimum viable product, which is something that essentially works. So everything after that is an enhancement. And as time goes on, the priority of those enhancements can change, because we'll have new threats, new technology, there will be changes, and things that are working are pretty good. So you can actually use the enhancements as a product, as a management tool for a project manager. So now let's talk about capabilities. Next slide, please. This slide illustrates how capabilities are defined and how they evolve. The origin of capability lies in JSIDs and capability description documents. We tend to describe capabilities using words. It's a common way a capability definition will start. So please click. The first thing we should do with the capability definition that we get is to break it down into things that there must be there for the capability to function at all. And I call this the core, and then things that are enhancements. So the core is the black thing in the middle. The enhancements are the colored things that surround it. I think it's critical to get agreement or validation that this definition is going to be okay with the people that wrote the capability description. The point, of course, is to get the right capability. In the paper, I use automotive cruise control as an example. So here's an example of an enhancement. Even with adaptive cruise control, you won't find a system out there that integrates navigation with cruise control. If you had that, it might allow you to slow down if the nav detects a police car in the road ahead. So that's an enhancement that would be enabled by some technology, and that's an example of enhancement. I think we all understand this. So we can use this definition to build, if you click again, a minimum viable product or capability. Could you click, please? So the minimum viable capability is represented by that blue circle that's in the center of that diagram. And you can use this to evaluate this with the project stakeholders. They might think that this is adequate. The minimum viable the light blue circle does intersect with the other enhancements, which is a good development practice that would enable the enhancement to be modified easily in a future release. So you sort of put hooks in there to make the enhancement easier to implement. Of course, the context for evaluating would be system-oriented, but the context for improving the system would be by enhancing capabilities. So click again. The prioritization of enhancement would be based on improving system performance. Capability evolution is derived from a performance gap and needs to be coordinated in an end-to-end mission thread. So maybe in this case, you can see the blue circle has gotten better. So we're at an enhanced capability release, and we've incorporated number 3 into the process. So it's incumbent on the capability developer to continue to identify future enhancements and enabling technologies. Capabilities rarely die. I'd also like to point out that this approach, a way of thinking about capability, it lines up perfectly with the core elements of Agile, like MVP and product backlog. Next slide. So we're going to talk now about digital engineering. There's a concept, it's not new, with respect to using digital system models for software development. It's becoming quite common. From an acquisition perspective, the typical need for digital engineering is to review contractor artifacts, which is not encouraging from our point of view. But in general, the need for, or the rationale for building a digital system model is to trade off an early investment in the model for late discovery of defects or issues. Late discoveries can be massively more expensive, or even compromise overall system performance or delay delivery of capability to the warfighter. Getting it right at the beginning improves our likelihood of success. But they're not silver bullets. They are a tool to be used by people that know how to use them. And I'd like to mention again the MB Synergy initiative at this point, because they are producing guidance for how to apply the modeling tools to improve an organization's efficiency. In other words, how to get more value out of the models and the modeling process. There's no question that a DSM can be built to represent the capability in the CNS. The question is how to build a process around this that's effective and efficient. Next slide. Okay, once we've decided to invest in a digital model, it's good to understand how we intend to use it and for what purposes. Several government organizations have already adopted this approach, and the term government reference architecture seems to be what they call this. I'm using the term generically, not with respect to any prior implementations. Please click. In the beginning, the need for the GRA is to work with users to make sure that you've got the capability right. So it's back and forth as the capability has been translated into MBSE. Click again. After the contractor or project team has been selected, the model is used to balance what the project team has developed with what was in the government architecture model. And it may need to change for very good reasons. And click again. So after that, the model is used as a communication tool to enable what's happening and how the system is evolving over time. And these are the reasons why what you could use this GRA for. And I've already talked about most of them. I'll also add it, the last one I haven't talked about before, but it does provide an opportunity to provide traceability between activities that you perform as you burn down the work and the user needs. Could you go to the next chart, please? Okay, this is explained in much more detail in the paper. I won't be able to do it justice. I will say that capability in general is defined by the users in collaboration with the project team and with the sponsor. Together, they develop discrete operational needs, which then get incorporated into a capability needs statement. The process that I'm suggesting would translate that into a model. The model will get validated. The validated model and those discrete elements would get incorporated into the backlog and to a roadmap. That's another Agile term, and also used for the acquisition. So that's the gray part over there on the right. The modeler, the project team would build their own model, and there would be a synchronization required, and they would deploy into some kind of a lab where the users could see what has actually happened. Again, this is described much more detail, but I'm sort of running out of time. Next slide. Okay, the last part of this presentation talks about a use case, and again, this is described in much more detail in the paper. The important thing is that there's different ways that you could actually implement this process, and I'll explain them in a few slides. But you need to have criteria for figuring out what's important to you. And I just have some generic criteria here that might be relevant to your evaluation. Next slide. So in this case, and I'm not going to talk about it in detail because I am running out of time, but we have like a program for infantry fighting vehicles. They find out that there's some conflict somewhere and undetected SUAVs are eating their lunch, so they need to do something about it, and they need a new capability. Next slide. They've got a model approach already, so they have already been investigating this because they're not idiots, and they had established, and they've got a roadmap, and they are doing Agile, so they're doing everything right. And they've identified for this capability upgrade that they could have a team to investigate alternatives, and they identified a bunch of different options for how to implement the capability. Next slide. So these are the three scenarios that I think are kind of most likely. So in one case, you have organic, program office, model-based engineering. I think that puts a lot of stress on the program to have competent people that know how to do this. I think but that'll probably get you there quicker. The next approach might be to use an external software architect that's on some kind of IDIQ contract with the government. They sort of act as a gray badge to do the role of the government, but they probably have likelihood of more competency, but it'll probably take a little bit longer. And the last option is to rely on the project team or the contractor to do this. And there you have an issue with potentially conflict of interest. Okay, next slide. And I'm quickly wrapping up. So big finish. Remember the policy math question that I asked in the beginning. So our answer is that it provides the environment to acquire higher quality technical solutions and provide them to the warfighter quicker. As I've been discussing, this is accomplished by using a model-based process to define and elaborate the capabilities defined in the CNS, enabling improved capability validation, more authoritative and complete reference for the program context. In other words, better definition of deficiencies, enhancements, interfaces, and interoperability, and better context for technical negotiations and communications. And we also provided a scenario that illustrates how this could be implemented by acquisition programs. So thank you for your attention, and I look forward to answering any questions. And next slide. Thank you.
Okay, thank you for that presentation. Please put your questions in the Q&A button. Next up is the last topic, transforming acquisition for speed, agility, and effectiveness. Ms. Rita Creel.
Thank you. Thank you. And good morning, and thank you for joining us. Today, I'll be talking about transforming acquisition for speed, agility, and effectiveness, and in particular, the work my colleagues Bridget O'Hearn and Carol Smith have been leading. Bridget has been leading work to develop resources for modern software acquisition, and that's the software acquisition go bag that Fred just referred to. And then Carol on a workshop approach to develop effective AI acquisition practices. Next. Okay, so next again. And so this is the problem that we've been facing with software. The legacy acquisition practices that we had for years are not a fit for software. They're not designed for speed, agility, adaptability, all the things that we need today for sure. Really, they were designed for hardware-centric systems with long timelines, sequential milestones, the concept of nailing down the requirements before we bend metal or begin a very expensive manufacturing process, which doesn't really apply for software. So that's what you see in the diagram, the left half of the diagram under legacy, and the box at the bottom with the old acquisition horse blanket that many of you may be familiar with. So software was brought along for the ride on this life cycle model, on this horse, with no codified way to take advantage of its flexibility. And in fact, resisting the flexibility has slowed progress in adopting the modern software practices. Even when Agile and DevSecOps practices and infrastructure began to gain ground, acquisition and systems engineering policy and practice were still largely in the legacy mode, with no real direction or guidelines or incentive to change. So the consequence has been limited ability to iterate quickly and respond to mission needs. And something needed to be done to enable us to use the full power of software. Fred mentioned the adaptive acquisition framework and the software acquisition pathway. So that's all part of what needed to be done. And, this was recognized by the Defense Innovation Board in their report from their software acquisition and practices study, the SWAP study. And the final report, software is never done. So in the figure, again, on the right, we're looking at the modern practices with rapid iterations, modular development, continuous delivery, and that highway sign on the bottom, DODI, the Department of War Instruction 5000.87, that's actually the software acquisition pathway policy document. Next. Okay, so just briefly, since Fred did mention it, the software pathway is one of 6 pathways that are part of the adaptive acquisition framework. So this in itself kicked off a period of transformation that's coming to fruition today with what we're seeing with the acquisition transformation strategy and all of the other directives that have been coming out. So it's a move away from monolithic, one-size-fits-all acquisition to reduce bureaucracy and deliver capability faster, again, to facilitate rapid and iterative delivery of software to the user. The SEI actually provided its research-based analysis and empirical evidence and policy expertise to help shape the software pathway, and that was released in October of 2020. So we've had a few years to actually begin to develop and mature and see what programs are doing. And you can see at the diagram on the right, the representation of the capability lifecycle that we use under the software pathway. You can download a larger version of this. There's a link on slide 6 where you'll be able to do that. So, the goals of the software pathway: remove defense acquisition constraints, apply proven commercial software development practices, and implement continuous user engagement. So the users, developers, acquirers, all working together to get rapid capability delivery to the field. So, just 3 things. It should be easy, right? So we'll talk a bit more about that in just a couple minutes. First, we're going to start talking about the role of the software pathway. So next slide, please. Okay, and again, we see the software pathway as an enabler of agility, speed, and effectiveness. And so if you look down at the bottom half of the slide, in fact, the software pathway is central to the 2025 acquisition transformation strategy, which we've heard about several times this morning. It calls for the speed, flexibility, and ability to deliver state-of-the-art capabilities at scale. So the software pathway, runs through all of the things that you see at the bottom, the bullets on along the bottom, on modular open systems architectures, model-based systems engineering, smarter contracting, better requirements, and revitalizing the industrial base. So software does have a central role in all of these, and it also benefits from all of them. And then go back up to the top half of the slide, and Fred mentioned the SecWar's 6 March 2025 memo directing modern software acquisition to maximize lethality. So again, it directs all components to adopt the software pathway as the preferred pathway for all software development components. And that includes weapon systems as well as business systems. And by calling it the preferred path. So one requirement of the software pathway is you need to be able to deliver capability at least annually. Now that said, even if your program is not a software pathway program, the practices that the pathway includes, it could be very valuable to your program to get it to bring it into the modern era, to make it make the metrics more useful that you're using, improve your requirements practices, and many other ways that it can benefit. So I believe now we have over 90 programs on the software pathway. Okay, next. All right, so we've talked about the policy shifts. Okay, now we have a policy in place, we have transformation strategy, but all that is still at a pretty high level. So if you look at the policy, there's no real, how do I do this? What's my roadmap? There's a good deal of information at the DAU website, the Warfighting Acquisition University website, under Adaptive Acquisition Framework that you can find about all the documents. There's not that many actually for the software acquisition pathway compared to what we used to have. The really minimal items that are needed, just the information that you need to successfully manage your program. But it is really kind of tells you what you need to do, but there's information that's missing in terms of how to actually go about completing the things that you need to do to be successful on the software pathway. Excuse me. So we've discovered in our work that programs shifting to this new way of doing business need some guidance. They need something that's practical, accessible, that won't take them months to learn or hours and hours to read. Tools, techniques, and examples that they can use today. So nothing that's 20, 30, 50 pages long. Even if you have the attention span for that, time is at a premium for everyone. So that's why we created what we call the Software Acquisition Go Bag. And it's a curated, extensible collection of tools to increase knowledge level and confidence of acquisition teams adopting the pathway. And everything that you have in the Go Bag is intended to be lightweight, short, useful, formatted for easy consumption, and grounded in real program experience. So we have what we call tactical guides, short, easy to read summaries on one of the activities that you need to get through that help you have some tips, tools, and techniques. We have supplements, and Fred referred to these. They augment the tactical guides. They include webinars, short videos, podcasts, some templates, and that sort of thing. And then we let you collect these all into a kit. And so we just began this effort in the fall, and our first kit is called the Software Pathway Essentials Kit. And this is based on the challenges that we saw programs facing who were adopting the pathway. And it's got 5 essential questions for you to ask yourself when you're launching the program, and the kit provides some answers, what to do, where to look for additional information, and so forth. So, we have Are You Ready? That go beyond just, well, to get on the pathway, you need an ADM, an acquisition decision memorandum, and you need a draft CNS, which Fred covered, but that's not all you need. You need also to be organized and equipped for successful execution. You need to know something about Agile. You need to know something about what modern software development looks like, what the acquirer's role is, how to provide a framework and ensure it's working. So We have actually a couple of resources for that. What is the software pathway and Ready, Set, Go? And you'll find those on our website. Fred covered number 2 about what is the capability needs statement and how do we develop one. We have 2 resources for that, cracking the CNS code and how does the CNS drive the process for creating working software. And we found that many existing programs, when they're transitioning to the pathway, they copy a CDD over and paste it into the CNS template, which kind of defeats the purpose of having the CNS. In some cases, we find that programs don't include information for requirements that aren't features, but they're threads through reliability, maintainability, security, and safety. So we found that some guidance was needed in that area. The next one, assessing progress. Maybe many of us, most of us have experienced where metrics require a lot of work to put together, to collect the data, to do the reporting. So we have a new resource that's actually was out just a couple of days ago called Pack Light, Measure Right, to just use the measures you need, base them on the information needs you have, and have the data tailorable to the audience and so forth. And the user agreement, which is a very important artifact, it's a handshake that explicitly links the development of capabilities to real-world warfighter outcomes. It's closely linked to another artifact, the value assessments, which allow users to provide feedback and return on investment data on value delivered. So there's a lot that goes into how to build a good user agreement, and we will be shortly developing, I think it's in progress, an artifact to assist you there. And then the release process. So how do you scope and sequence your releases, your minimum viable product, your minimum viable capability release, and subsequent releases. So, these represent some of the areas where we've seen programs stumble. And so hopefully you can get some use out of those. And you see the link and the QR code at the bottom for more information on that. Next, please. Okay. And so this is just sort of well, is this relevant to me? Well, actually, each of the resources goes through not just what is this, who needs to care about it, and what does each role need to care about it, and then some additional information. So anybody who is involved in an acquisition that has software could benefit from using the GoBag resources. So I think we can go to the next slide. Okay, so everything that we've talked about so far applies to software broadly. But today's acquisition challenges increasingly center on AI-enabled capabilities. And AI introduces a lot of new considerations. And I think you heard that from Nick and John in the first presentation in this panel. AI development cycles are different from conventional software. There's a very, very, very heavy necessary emphasis on the quality and relevance of the data that you're using to train your models, and the data that you're ingesting as you're inferencing and retraining. And so these all require new oversight mechanisms, and they introduce new forms of risk, especially for our national security systems. So this is why the SEI led an initial workshop in fall of 2025 to capture some practical experiences and lessons learned on acquiring AI in realistic operational environments. So we don't have the 100% answer now, but we're working towards it. So just to, briefly, this is a list of the topics that really came up strongly during the workshop. And the paper that accompanies this presentation has more on each of these topics. So just a couple, don't lead with the technology, lead with the operational problem. So that's start with the mission need. Oh, this is a cool AI thing. Let me see where I can shoehorn it in. Well, it's cool, keep it in mind, but really, what is your operational mission need today? And both of the next bullets on selecting, preparing, and managing data, very important. I mentioned that briefly, but as far as data preparation and management, a lot of effort goes into, acquiring the right data for training, getting it ready, and then paying attention to the data security throughout the whole time that you're using the model, training it, and so forth. Understanding a little about how the model works, at least at some level, if there are interpretability mechanisms that have been included, why is the model making certain decisions? And this feeds right into the next one, to prioritize trustworthy systems. Warfighters need to know when an AI system is uncertain or when it's degrading in performance. So there, you can't, it's hard enough to measure reliability on regular software, traditional software, and on AI systems, it's even more of a puzzle. We've talked about, on the second column, modular systems, and they can be very important if you need to swap out a particular AI-enabled capability for another. Is it easy to do that? Are you going to have high risk in doing that because you haven't got well-defined, clean interfaces and the modular approach? Pilots before you issue a contract are also important. And then again, making sure that you have enough of a human engagement with the model, not just a set and forget. You can't do that with AI. And finally, plan for failure. What does it mean? Am I managing risk appropriately? And next. And that's it. And this is our team, and you can get a hold of us at our emails here. And also, please do go visit our website for more information on AI engineering, and on our software acquisition go bag. Thank you.
Okay, thank you. All great presentations. So a couple of questions. We're having a little bit technical difficulty, but I do have a couple of questions. As the department continues shifting towards software-defined AI-enabled systems, where do you see the greatest integration and test risks emerging between digital engineering models and real-world operational capability delivery? So there's no person really identified or topic, but I'll open it up to any of the panel members want to take this one on.
You want to start?
I think there is a real opportunity to keep the digital engineering models consistent with the deployed systems as they evolve. I think a lot of legacy implementations have allowed their digital models to lag in keeping up with the systems as they develop. So I do think that there's an opportunity here. If you want to use the digital engineering model as a way to mitigate risk for when the actual test is conducted with the real operational capability. So I think that this is it's an unsolved problem, but I think there's a huge win if we can figure it out.
Yeah, I'll just add, I think one of the challenges we've seen to really keep the models current with the real deployed systems is, the feedback loop of operational data into the development pipeline, because there can be classification issues with the data. So I think that's been one of the challenges that I think people are trying to take on. I think another aspect is, the compression of the development pipeline. People, specifically warfighters, want a faster iteration cycle. And that means that, everything has to be viewed from that lens. In other words, I think things in that process that are bottlenecks or slowing it down, like, for example, incompatibilities with different systems or across different development organizations, there's going to be less acceptance of those kind of things. And so I think those are solvable problems. But I think that, in terms of the challenges ahead to really bring those things together, I think those are not always easy to resolve unless you have, one sort of tool set, framework, which often is not the case. So I think bottom line is those kind of things will be worked for faster iteration cycles over time.
Yeah, Yeah, and I agree with what Fred and John have said. With keeping a digital model current, if there's a way to, reflect back, have changes reflect back to the model, is it in some sort of an automated fashion. Of course, we're a ways away from that, but it does remind me of, not keeping the documentation up, the paper documentation up when things change. I mean, they're good on the day they're released, and then nothing ever happens to them after that. And we're in a completely different world now. And I think it does merit planning and really thinking about, do we really want to be fast? And this is one way we can be to make sure we have this consistency and alignment.
Okay, thank you. Next question is for Mr. John Roberts. With the change from JSIDS to the JFRP, how do we ensure that the services are using digital engineering and model-based system engineering techniques to collaborate properly to produce capabilities efficiently?
Yeah,
Would
so,
you want to
yeah,
get the digital engineering? I'll let Fred take it.
yeah, I think this is more for me. But I would say that if we're talking about common capability and how we can leverage something that was developed over here with this program for something that's now over here with this other program, we have an opportunity for like a product line approach to the capability, and then things ought to be a lot easier when we are transitioning and using the digital engineering tools to produce what we are expecting. I mean, I think that's sort of the vision. I mean, certainly for things like position PNT, we have things. We have the need to know that type of information for every system on the planet, and that should be a common capability. And we have, but again, we have this age-old problem with sharing things across the service boundaries. But that's how I would expect it to work. With the more common the capability is, the more likely it is that you would be able to use those techniques and those legacy artifacts to develop the next version of the thing and keep things synchronized that way.
I'll just add, I think part of what we, Nick and I and Doug, were trying to express is in the software-defined warfare model or approach, even though commonality helps with product line approaches, like Fred said, and is absolutely a proven solution in industry as well as government solutions, and that is necessary. The software-defined warfare environment enables a level of rapid customization to fit the battlefield, which I think is really important. And we want to enable that and support that because it can prove the difference in certain scenarios. So I think even though we're focused on common capability and reuse of capability across systems, I think that increasingly there's going to be a desire for, especially agent-supported or agent-native solutions that enable rapid development and deployment. Over.
Okay, thank you. So I actually have one question. So that we are making sure that the department and the programs invest in modeling and simulation early and make sure they establish the system engineering rigor early. One of the things in the acquisition transformation strategy, it says we need to streamline regulations. Can you think of anything in the current regulations that could be streamlined that may not add, some value to the whole process? I'll open that up to all three of you.
How wide can we go? Right.
I guess how wide you as wide as you want.
I'll say a couple of words here. I know for software, because we have the software pathway, excuse me, and we have the memo from the SecWar, and it actually says that the services are not supposed to layer any additional requirements for software on the programs that are trying to execute that. And we've seen that not work out at times, where it's like, no, you need this, and it's clearly it's a hardware worry and really not necessary, but it's sort of eaten into time better spent elsewhere. So, and I understand people are worried about risk, and it's hard to move to a new way of doing things. So maybe it's education. I don't know, but
yeah, I'll jump in. I mean, I just think in general, it's really more about removing barriers that would occur when you try to do something. And and I think we are still in early days with modeling and simulation and how that is being implemented inside of the programs. And I mean, in some areas, I'm talking now about software, but I mean, in other areas, we're very mature. But in software, it's still very early. And when you try something and you're doing something different and you just run into the roadblock, we can't do it that way I mean, that's really the types of barriers that really stifle creativity and a natural, innovative approach to how you do things.
Again, I'll just add, I think I don't have specific regulations that I can point to and say those are outdated or those are barriers. But I think the framework we use to sort of assess that question is to think about software-defined warfare and how the transformative nature of it changes things. So, for example, testing that we talked about, there's all types of testing, unit testing, integration testing, operational testing, and how these are considered typically distinct activities, maybe done by different organizations. There can be different sort of accepted approaches about deliverables on all those fronts. I think if you look at a continuous approach where it's highly integrated and those lines are blurred, then any regulatory framework that sort of explicitly points to, sort of the older way of doing things and inhibits the newer way of doing things. I know that's a general response, but at the same time, it turns out that, some of these things are regulatory in nature. Some of these things are done by development organizations, that are their internal processes. And sometimes it's just sort of a cultural difference. So I think there's going to be a range of things we're going to have to overcome and adjust to really maximize the benefit from this opportunity.
Okay, thanks. Great input. Let's see, one more question here. How does the software pathway apply to non-Department of War vendors that have a COTS solution that the vendor believes can be quickly adapted for deployment?
Okay. So that's a great one. So as far as contracting, you are buying a commercial solution, you are going to adapt it, of course. It's the contractor will have their own processes. Now I'm assuming you want the same contractor to adapt it, or you're going to bring it in. I mean, there may be a number of questions you need to ask about that. But in terms of the software pathway documents, you're going to have some kind of a strategy for how you're going to acquire it. What do you know about the adaptations that you are planning? What are the capability needs that are being met? Who are the users? So the basic stuff that the software pathway requires would be actually helpful, even if you don't have to take the whole software pathway and execute it the way you might normally. So that's one aspect, and you do need to be engaged somehow to make sure that the adaptations are going to meet the needs that you've laid out. So I think that you would find it helpful, even if you're not officially declared as a software pathway program. There are also, I'll mention this, there's some international standards that actually apply. There's a standard for procurement of AI that the IEEE put out, and that's really for commercial solutions. I haven't read the entire document. If one of you have, please feel free to jump in. But it does talk about steps for risk reduction and various tools and templates you can use that you might find helpful. And while I'm on the topic of standards, there's an ISO standard for AI system lifecycle processes. And so another another area. So there's a proliferation actually of standards, but those are the ones that are basically talking about AI-enabled systems, life cycle, and on one hand, and then procurement on the other. And it's IEEE 3119, and it's ISO IEC, I think it's 5228, 5288. I don't, I'll get that. I don't have all the numbers in my head right now.
Okay, thank you. Kind of a late breaking one here. I'll have to read this one. Are there any roadmaps or guidance that provides the critical changes needed to go from how entire systems are developed and deployed today to being able to develop and acquire systems in a continuous integration and continuous deployment paradigm?
Well, I mean, this isn't the topic of any of our presentations, but we have a whole research program at the SEI that is all about this particular topic. So we do have guidance, and we do have artifacts that can help people like yourself to understand that transition and figure out what you need to do in order to make that happen.
Yeah, to add to that.
Would you mind if I? I'm sorry, would you mind if I jumped in just for a second?
Please, Nick, go ahead. Yes.
As it just turns out, I wrote a paper on this exact subject in a previous acquisition research symposium where I looked at the different software pathways, the different pathways, including software, and that if you take a look at a major capability acquisition, which is like an airplane and mission systems and weapons and all the other things we usually package up in a big, huge acquisition, how you can break that out into, well, if you're going to do modeling and digital engineering, that sort of thing, it sounds like the business pathway. Well, your aircraft has got a whole bunch of software in it. Well, why do that under the authorities and auspices of building an airframe, right? Use the software pathway. So you could actually compose a set of pathways to achieve an overall large capability acquisition by taking advantage of the different authorities, business models, and contracting approaches that are specific to each type of activity for your reading pleasure.
You'll look for that. And I also wanted to mention that the DAU Adaptive Acquisition Framework website does have under each of the six pathways, there like the major capability acquisition has vignettes that shows combining the difference, say the software pathway and major capability acquisition, or software pathway and middle tier of acquisition. But I think that Nick's paper would be very, very useful to you as well. So it gets into some of the details that the website does not.
Right. I think the awful part of using those pathways is all of the sort of regulatory. Those are that's an answer to the other question that you asked a few seconds ago. But if you are combining the pathways, you may have a hybrid approach, and you may be able to try to kill several birds with one stone with the paperwork that you have to go through in order to satisfy all of those different pathways. That's like, you know, we're nowhere near there yet, I don't think, but yes. You never know. Right?
And then you have to get everybody to agree to sign
that's
up.
Right.
And that's really, those are some of the barriers that have not gone away.
Right.
Okay, great, thanks. I think you've already touched on this one, but there's a separate question. How do we ensure that services and agencies can share digital system models to reliably test systems and capability dependencies?
I'm sorry, could you repeat the question?
Yeah, how do we ensure that the services and agencies can share digital system models to reliably test systems and understand, I guess, their capability dependencies?
I think we didn't we answer this question already?
It was a separate question that you kind of answered. I'm just scrolling through them right now. Sorry, but I'm.
Well, okay. I mean, again, I think it's sort of like, as I said before, it's sort of across, or even within a service or across services, it really depends on how reusable or how opportunistic the capability is that we're talking about. Some of them are going to be very focused on, like ship control, I mean, navigation, or what, in water. That's like extremely Navy focused, and probably is very similar across the ships. Maybe not. I don't know. I'm not an expert on that, but other things ought to be more applicable. And you should be able to share the digital models across platforms, at least at that level, in order to get to save time and avoid reinventing the wheel and so on.
Okay, great. I think we're towards the end of the time limit, but I want to thank all the participants. Great discussion. The department is trying to transform acquisition, stressing the need to make sure that we invest early in the modeling and simulation. And I agree, this is a cultural change that we're going to have to address, through training and other things to make sure that the workforce understands the need to transform so that we can maximize speed, agility, and effectiveness, right? I've heard the Deputy Secretary of Defense, he keeps talking about speed. He wants to speed things up. So we are definitely trying to do that in the Department of War. So I have I have 2 minutes left. Does anybody want to have a closing note or plug?
I think this was a great panel. I really appreciate everybody's diligence to producing their papers and presentations. I thought it was excellent. Thank you.
Yeah, I think there's a lot of exciting opportunities to really help the warfighter in the current environment with the rapidly changing technologies. And given the rapid changes in the battlefield, it's also urgent. So I think this is a time where we can bring some of those new opportunities to bear for the warfighter.
Yep. And remember, everything has software in it. And, so do go visit our software acquisition Go Bag page. And we also have a feedback button. So if there's something that you want a resource on, we're lining them up in our backlog to work on. If you have questions, something you don't like, something you want to change, please do contact us.
Okay, thank you, everybody. Thank you, panelists. That concludes our session. Please refer to the Symposium program for a link to the next scheduled event. And thank you for attending out here.
Bye.